Another calculation that we have on vectors is cross product. But before we do cross product, it helps to understand these things called determinants. In order to determine it, well, you got four parts. A, B, C, D, means various things, but the determinant of those two, which is represented with the vertical bars there, so this is the determinant on order 2. Go into a lot of things, but really all you need to know is how to calculate these. So to do a determinant, what you do is you take the A times the D, and then subtract B times C. So you got to change. That's one way to think of it. I guess there's different ways, but yeah, you just do. It's kind of a cross product sort of thing, but that's the way those are calculated. So just to do one example here, so we have it. So the determinant here. So you do 6 times 4. Minus 3 times -2. So that is, again, just a number. In this case, we'll do something a little different in a second. But what is that? 24 plus 6, 30? So that's a 2 by 2. The one that'll apply to us is when we have a 3 by 3, if you will, order 3 determinant. Yeah, so A1, A2, A3, B, B1, B2, B3, and C1, C2, C3. It gets a little more complicated, of course, when we go to that large one. I think that's as far as we do, as big as we'll do it. But yeah, to do that determinant, what you do is you take well, really, the way you can look at it is I'm going to take all of the top ones and multiply it by a 2 by 2 determinant. So I'm going to take A1 times, and if you think about it, here's the way it goes. I'm going to take A1, forget the first column and first row here. So that's going to give me that, if you will, determinant, B2, B3. So you multiply it by that determinant, B2, B3, C2, C3. All right, then we do the alternating signs thing. So then we do the same thing with the A2 component here on top. So we do the A2 minus the A2 times then the determinant. We'll cover up the first row and the middle column, and so that gives me B1, B3, C1, C3. And then do the same thing with A3, but it's plus A3 times the determinant of, cover that up, so you got B1, B2, C1, C2. Looks kind of bad, but it's not really. All the sub numbers there, but it's really not that bad. Okay, so here's an example. All right, so we got 3, 4, 2, -1, 8, 7, -5, 6, -3. The determinant of that. All right. So let's probably, for me, helps to write. So I take the 3 times, forget the first row and first column, so that'd be 8, 7, 6, -3. And I do minus the second one on top, 4, times the determinant. So forget the middle column and the top row, so it'd be -1, 7, -5, -3. And then the 2, the last one on the top, the determinant, multiply that by would be negative 1, 8, negative 5, 6. Yeah, so those aren't that bad then to do. Because yeah, this then is just the 2 by 2, which we know how to do from the previous. So you got negative 24 minus 42. Then you got minus 4 times.
I think that negative 7 is supposed to be positive 7 on the second one.
Oh, this one?
Negative 1, yeah.
Yeah, I don't know. I got negative 7 from. Yeah, because that is the hard part, is the signs,
Yeah.
keeping the signs straight.
Yeah.
So if you copy one over, that's gonna throw y'all off. All right, so then, what do we got? Negative 4 times what would be 3 minus negative 35. And then you got 2 times negative 6 minus a negative 40. So it's just, in this case, it's just numbers. Now we'll do, the way we're going to use this is a little something, a little bit different. So what is that? 3 times negative 66 minus 4 times positive 38, and then 2 times, what was that, 34? Check on those, but. I get negative 282. Negative makes sense there. I think that's right. Is that okay? Leave that? Okay. All right, so yeah, so that's helpful. That specifically is helpful with this cross product. It's called the cross product. Because here's what the cross product is. All right, so for 2 non-zero vectors, three-dimensional vectors, I should say. For 2 non-zero three-dimensional vectors, we get this cross product, A cross B. All right, let me just talk here about that for just a second. The reason we are wanting a cross product for our purposes that's coming up next is we're going to want a vector that's perpendicular, orthogonal to these two vectors. And that's what the cross product is. It's a cross product is a vector that's orthogonal to A and B. Both. Or whatever two vectors you're crossing together. So that's the motivation behind this, is I'm trying to find a vector that's orthogonal, perpendicular vector, to both A and B. And you'll see why we would want one of those, what we do coming up next, but for right now, let's just compute here, figure out how to compute these, all right? So here's what it is. A cross B, so we're talking about three-dimensional vectors, so I'm going to take A1 let's do it in IJK form. All right, so we got A1I plus A2J plus A3K. cross that with B vector. So that's going to be B1 I plus B2J plus B3K. Just mixing my notations there. Okay. So we're crossing those two. That's the two. Well, here's what it is. Here's the formula. This is not how, I don't remember this formula, so just beware, but I'll show you how to do it without really having to memorize this. All right, so what is it? I mean, I guess you can memorize it. So it's A2B3 minus A3B2J, I. Plus, you can see why I don't want to memorize this. A3B1 minus A1B3J, so that I don't want to have this memory, plus A1B2 minus A2B1. Okay. That's cross run. Lots of numbers, lots of letters. Except I don't really remember that formula there. Here's why. Here's what I can do. This formula is a whole lot easier if I arrange it this way. Okay. All right, so A cross B. If I arrange it in a determinate form, I don't have to remember that because I know how to do determinants, or can figure it out, or it's more, to me, it's easier to think about this way. So just do the determinant where the first line, the first row of the top of the determinant is IJK, those basis, standard basis vectors. And then the other two rows are the components of our two cross product values, right? So that's A1, A2, A3. So that's the components of A. And then B1, B2, B3, components of B. Then you don't have to remember that, because then you can just do the determinant. Just remember how to do a determinant, which to me is easier to remember. Yeah, so let's just, this is how I remember it, how to do it. Yeah, so you see here, what you get is what we got there. If you do this, so you take, remember how we did it, so we do the I, just verify that that's the same. So it'd be I times this one right here, right? A2, A3, B2, B3, determinant, that 2 by 2 determinant. Then we got minus J times, all right, so forget the top line, forget the middle row, so you got A1, A3, and B1, B3. And then plus K. So you forget the top line and the last column, so you got A1, A2, B1, B2. Yeah, so you can see where those come from, all right? So, yeah, that right there is going to be this, right? Just to do that determinant, you do A2 times B3, and then minus A3 times B2, right? That's what you get. So that's where that comes from, so to speak. Now this one, I think it's, the reason it's backwards here is because of the minus being factored in there, right? Because here you got minus this determinant, which let me write it out. So the determinant here would be A1B3 minus A3B1. Well, if we factor that minus in there, that's what we get, isn't it? Ta-da, okay. So it all works out. And then the K time, so it's A1B2 minus A2B1. Yeah. a lot easier to remember. Arrange that way. Okay, so let's do one here. Yeah, we've got time, so. Let's do one here and then we'll verify that they are orthogonal. Okay. So A is 1, 3, 4. B is 2, 7, negative 5. And, you know, going back and forth between the notations here because it seems like the book does them in kind of random fashion too. They pick to do IJK sometimes and sometimes they use this notation. So just get used to that. Throw it at you every once in a while. Okay. All right, so A cross B. Cross product of A and B. All right, so we're going to do it that way. Let's add I, J, K, determinant, top line, and then 1, 3, 4, the A's, and then 2, 7, negative 5, last line. All right, so that would be I times this determinant, 3, 4, 7, negative 5, minus the J times the determinant, 1, 4, 2, negative 5, plus then the K determinant is 1, 3, 2, 7. Yes? You did all right? Yeah, so then it's just 2 by 2. Those are easy. So the determinant here would be negative 15 minus 28. Then we do minus J times negative 5 minus 8. And then K times that determinant would be 7 minus 6. The numbers are pretty easy on that one. So it'd be negative 43I. So you got a minus and a minus, so it'd be plus 13J, right? And then plus 1K. So it's not that bad. It's a little more complicated, of course, than the dot product, but so yeah. So comparison between dot product and cross product. So the dot product is a scalar. It's just a number. But what about the cross product? Cross product is a vector. So yeah, it's a more complicated thing. When you do a cross product, you get a vector out of it. Okay. Now let's, and we know it's a special vector. So the cross product, we said, how is it related to A and B? It's orthogonal, right? So this vector should be orthogonal to A and B. So let's verify, okay? Verify here that A cross B is orthogonal to A and B. We'll do it here. How do I do that? How do I know if what's the easy way, I guess, to put it? Orthogonal means they're perpendicular. What's the easy way to show that they're orthogonal? It's the dot product, right? If the dot product of two vectors is 0, then they're orthogonal. Okay? So this just means show that if I do the dot product of A cross B, dot that with just A, see what that is. We know that if they're orthogonal, it should be 0, so that's what we're showing. It's showing that that's 0. All right, so what do we get there? So take this vector here and dot it with this vector. Easy enough, dot product, you just multiply the components and add them together. So it'd be negative 43, right? So do negative 43 times 1. You got 13 times 3, that's 39. And then 1 times 4, hey, look at that. orthogonal. It's a dot product 0. Now the other one, A, so we got the other consideration. Take the cross product times B. What does that give me? So that'd be negative 43 times 2, that's negative 86. Plus 13 times 7, 91. It's getting late in the day here. And then 1 times negative, hey, look at that. Negative 86 plus 91 minus 5, ta-da, 0. So both of those dot products are 0, meaning they are orthogonal. So just the way it works, okay? Now the other part to this, okay, so we've got this, this cross product gives us something that's orthogonal to both vectors. But there's another consideration, that is, in which direction? Because, all right, let's think about it. Let's say I have two vectors here. Let's do it this way. Okay. Here's vector A, and here's vector B. Well, which way is A cross B going to go? Because there's two possible ways this could go. Now, I've drawn them parallel, if you will, to the surface of the board. So they're in the plane, they're in that same plane of the board. But if you think about it, I've got a vector that's perpendicular to both of those. So it's either got to go out of the board, up, or it's got to go into the board, right? But it could go either way, because a vector has an initial and a direction, terminal point. So it has a direction. So it could be either going out or it could be going in. Well, what they use here is what's called the right-hand rule. You take your right hand, I can spell rule. You take your right hand, and if it's A cross B, you start at A and then rotate your hand around in the direction of B. So A cross B, and wherever your thumb points, that's the direction of the cross product. Okay. So in this case, A cross B is going to be coming out on the board. All right, so let's see. If I do let's say I do let's see, some are harder than others to do. Okay. All right, so here what's the direction? Well, you have to get your hand around. So, but this one's easy because if I just stand over here. All right, so if I go A cross into B, it's going out again. Let's get one. Try to get one that's into the board. Yeah, just flip those around. So yeah, you got to use your right hand for this. It doesn't work. It might be easier to do the left hand, but yeah, this works. It's the right hand. So yeah, I'm going to rotate A, trying to rotate that. So I've got to same thing. No, I'm good. Okay, so A, rotate.
That's out.
What am I doing? Oh, yeah, like this. Yeah, so you got your A rotated into B. So these fingers have to sweep into that, so yeah, that's inside, into board. We're gonna do the paper down, up or down, however you want to say it. Okay. There's just one other formula let me mention besides that. Kind of like the dot product, there's a formula for cross product. Cross product, where the magnitude of the cross product the magnitude of the cross product. So when we do the cross product, that gives us a vector. Well, certainly we can get the magnitude of that vector off of the vector itself if we've got it. However, like the dot product, this magnitude of the cross product can be computed another way, and it's similar to that dot product formula, magnitude of A, but it actually uses the sign. Magnitude of A cross B is the magnitude of A times the magnitude of B times the sine of theta, where theta is the angle between A and B, and then theta is comes out here between 0 and pi. We want the theta between 0 and pi. So yeah, that, if we know the angle between the two vectors, we don't have to go into all the cross product stuff, because we just the magnitude of A, magnitude of B times the sine of theta. Now, knowing that angle, that's another story. I mean, I guess you could get it various ways, but anyway, just here's another formula that we can utilize. So yeah, so here's the way in this particular section how they get us to use this formula. All right, so let's say I've got I want to find the magnitude of A cross B, but here's what I know. Oh. I got a little diagram. Here's A, and its magnitude is 6. Here's B, and its magnitude, well, better draw a little here, is 5. And I know this angle here is 150 degrees. So that would be hard to construct. Back construct here what exactly A and B are as far as vectors, the vector components. But I don't have to do the cross product. I just want the magnitude of the cross product. And so that's how they get us to use this formula. I don't need the actual cross product. I can just use this formula because I've got the right information. I've got magnitude of A, I've got the magnitude of B, and I've got theta, so I can compute its sine. You see? So anyway, magnitude of A cross B is magnitude of A times magnitude of B times the sine of theta. One thing, all right, so that's easy. We got 6 and we got 5, and then we've got the sine of 150 degrees. The only thing is, you know, usually we have our calculators in radians, set in radian mode. So if you put in sine of 150 and you don't say that's degrees, then it's doing 150 radians. So you know, put the degree symbol on it. Or the other alternative here is, this is 30. is go ahead and convert that to radians, which would be 150 times pi over 180. That would convert it to radians. So we won't have to worry about messing it up here. Or you could change the mode to degrees, but then you need to change it back to radians for most things. So anyway, so what is it? We can simplify that. Let's just do 15. Let's see what's 15. So the magnitude of that A cross B would be 15. What's the direction of A cross B? Well, again, you need to get, so here's A, so I need to get my hand whichever way, but I need to rotate this through that angle. It's into the board, right? Down or into the board. Or paper or whatever. However you want to phrase that. Okay. Well, about out of time there, so.